Usually when we talk about artificial intelligence, you probably picture this massive omniscient brain just doing everything for you.
Right, yeah, like this giant supercomputer.
Exactly. But today, we're looking at a pretty fundamental flaw in how companies actually use that brain. Welcome to the deep dive, by the way. Our mission today is to unpack a technique called LLM model routing.
And it is quietly slashing AI infrastructure costs by up to 85%, which is wild without even sacrificing quality.
Yeah, 85%. We are synthesizing some major research today to explain this, specifically papers like FrugalGPT and RouteLLM, along with a few, technical engineering guides. So to start us off, what is the core problem here?
Well, the core problem is basically just massive overkill. Right now, most AI applications are sending every single user query to an expensive, massive frontier model.
Like GPT-4 or something similar.
Exactly. No matter how simple the prompt is, they send it there. You are essentially firing up the supercomputer just to do basic arithmetic.
I feel like it's like paying a master architect's massive hourly rate to physically lay bricks. You need the architect for the complex planning and the blueprints, obviously.
Right.
But you should really just hire a cheaper junior crew for the routine building.
Yeah, and the numbers absolutely back up that exact analogy. Frontier models can actually cost up to like 34 times more than smaller models.
Wait, 34 times more?
34 times. It's huge. And studies from RouteLLM and FrugalGPT, they prove that if you route queries intelligently to those smaller models, you can cut inference costs by 40 to 85%.
And the quality?
You still maintain about 95% of that frontier-level quality.
Wow. Okay, with savings that huge, the obvious question is, how does the system actually choose who gets the job without slowing everything down?
So the simplest framework is cascading, which that was highlighted in the FrugalGPT research. Basically, you give the task to the cheap model first.
Okay.
And if its confidence in its own answer falls below a certain threshold, then it escalates the prompt to the expensive model.
Let me stop you right there, though, because waiting for the cheap model to stumble before finally calling in the architect, that feels highly inefficient. Doesn't that just, double the wait time for the user?
It definitely can, yeah. Which is exactly why developers move toward a second approach, which is classifiers.
Okay, what's that?
This is the method RouteLLM uses. So instead of waiting for a failure, you use a tiny, lightning-fast model to just predict which LLM is right for the job before the answer is even generated.
Wait, so how does it actually know without running the query first? Is it just looking for keywords or?
It's deeper than that, actually, and this brings us to semantic routing. The system embeds your query, essentially turning the text into mathematical coordinates.
Right.
It then measures the literal distance between those coordinates and similar historical questions. So if it sees that past queries in that same sort of neighborhood were successfully answered by the cheap model, it just routes it there instantly.
But even with these mathematical shortcuts, adding a middleman router has to introduce some latency, right? You're adding a whole extra step before the AI even starts thinking.
You would think so, but the classification step is just a single mathematical operation. It takes less than 100 milliseconds.
Oh, wow. That is fast.
Super fast. Because what really causes delays in AI is autoregressive generation. That's the system constantly recalculating probabilities for the next word, token by token, on a giant model.
Ah, I see.
Yeah, so bypassing that heavy generation for a simple task saves drastically more time than the router takes to make its, sub-100 millisecond decision.
But if the router is making these snap decisions in under 1/10 of a second, it can't be perfect. What's the fallout when it inevitably misjudges a prompt?
That is what engineers call quiet misclassification, and honestly, it is the biggest danger in routing.
Quiet misclassification.
Yeah. So a router mistakenly sends a highly complex prompt to a cheap model. But the cheap model doesn't fail or trigger an error message. Instead, it returns a very confident but entirely hallucinated wrong answer.
Ah, so the junior builder just confidently builds a crooked wall and nobody double checks it.
Exactly. And it gets worse, actually. There is a second highly technical trap, which is KV cache destruction.
KV cache?
Yeah, the KV cache is basically the AI's short-term memory of a conversation's prefix. Like, if you have a long chat going, the AI uses this cache to remember the context.
Right, but if the router is constantly bouncing my prompts between a cheap model and an expensive model, depending on the question.
It scatters those requests across different servers, and that just destroys the short-term memory.
Oh, no.
Yeah, the system is then forced to reread your entire chat history from scratch on the new server. This causes massive cost and latency spikes. completely wiping out the savings you got from routing in the first place.
Man, so developers have to be incredibly careful about how they implement this.
Very careful, yeah.
But it seems like the overarching takeaway here is that model routing transforms AI from a static, expensive tool into this dynamic, highly cost-efficient ecosystem.
Right.
I mean, you don't just need one massive brain anymore. You need a managed team of them.
Exactly. Which, leaves us with a pretty provocative thought to consider.
Let's hear it.
As these routers become flawlessly predictive at matching microtasks to specific models, will you eventually stop interacting with distinct branded AI models entirely?
Oh, like no more GPT or Claude by name?
Right. You might just interface with an invisible, shifting swarm of specialized intelligences all working seamlessly behind the scenes without you ever really knowing who is laying the bricks and who is drawing the blueprints.